Hi, today I'm going to explain these two questions. The first question is: an army contingent of 616 members is to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? First, read the question carefully. From this question, we will get the number of persons in an army contingent and the number of persons in an army band. See here, in the question it given that they are marching with two groups. What are the two groups? The band and the army. Just imagine that groups. Band with 32 members and army with 616 members. And it having equal number of columns. Here, these lines are representing the number of columns. These are equal. So, let us take n be the number of columns. In each column, how many members are there? That also we don't know. So, consider with some variable. In band, the number of persons in each column is A. In army contingent, the number of persons in each column is B. We already know the number of persons in an army contingent is 616 and number of persons in an army band is 32. This 32 we can write as n into A. N is the number of columns into number of persons in each column. Similarly, number of persons in an army contingent is 616 equal n into B. This n is the number of columns into number of persons in each column. See here, in both n is the common factor. What we have to find? We have to find the maximum number of columns. That means it is the highest value. Therefore, we have to find the HCF of 616 and 32. How we can find the HCF? You have to apply the Euclid division algorithm. The algorithm step 1, observe the values A and B and check A greater than B. Then divide A by B. Here A equal 616 and B equal 32. 616 is greater than 32. Now divide 616 by 32. 132 is 32. The remainder is 29. This 6 will come here. 932s is 288. The remainder is 8. This we can write in the format 616 equal 32 into 19 plus 8. The step 2. What is step 2? Check whether the remainder is 0 or not. Here the remainder is 8. We have to apply the Euclid division lemma again. Now A equal 32 and B equal 8. 32 is greater than 8. Now we can divide 32 by 8. 8 fours are 32. The remainder is 0. See here step 2. If the remainder are equal to 0, B is the HCF. What is B? B is the divisor. Divisor here is 8. Therefore, the HCF of 616 and 32 equal 8. That means they can march in 8 columns. The maximum number of columns is 8. Now we will move to another problem. The problem is: use Euclid division lemma to show that the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. In the question itself they are giving some hint. What is the hint? Let x be any positive integer, then it is of the form 3q, 3q plus 1 or 3q plus 2. Now square each of these and show that they can be written in the form 3m or 3m plus 1. Let us try. What is given in the question? X be any positive integer and b equal 3. How we are getting this b equal 3? From this and all. 3 and plus 1 we will get. How? What is the meaning of this? Take one positive integer x, divide by 3. We will get one quotient and the remainder r. This we can write x equal 3q plus r, where 0 less than or equal to r less than 3. What is the meaning of this? This is the remainder r is less than 3. That means it can be, that remainder can be 0, 1 or 2. We will get three possibilities. Now we can check that. The first possibility, if r equals 0, means, see here, this r. Instead of this r, we are giving 0. Now x equal 3q. Squaring both sides. X square equal 3q whole square. What is 3 square? Is 9. Q into q, q square, 9q square. This 9q square we can write 3 into 3q square. Let us consider this 3q square as m. Now we can write x square equal 3m. The next possibility, if r equal 1. Instead of this r, we are giving the value as 1. Now x equal 3q plus 1. Squaring both sides. X square equal 3q plus 1 whole square. How we will expand this? We know already a plus b whole square equal a square plus 2ab plus b square. By using this, we can expand. 3q whole square is 9q square plus, see here, 2ab. 2 into 3q into 1 is 6q plus 1 square is 1. From these two terms, we can take 3 as the common factor. Now we can write 3 into 3 square, 3q square plus 2q plus this 1. Consider this 3q square plus 2q as m. Now we can write x square equal 3m plus 1. The last possibility, if r equal 2. X equal to 3q plus 2. Square both sides. X square equal 3q plus 2 whole square. 3q whole square is 9q square plus 12q plus 4. These 4 we can split 3 plus 1. From these 3 terms, we can take 3 outside. Means it is the common factor. Let us consider 3q square plus 4q plus 1 as m. Now we can write x square equal 3m plus 1. That means square of any positive number can be expressed of the form 3m or 3m plus 1.